Permutations and combinations. This is a most general topic, we can say. It's a general topic which can be taught even to a common man who can calculate all the problems in this one without the knowledge of any engineering subject. Like further, this is such a topic which will come throughout your career, like even if you go for any competitive examinations also, it will come. So before entering into the topic permutations and combinations, and let me first explain you what is the principle of counting. You can see that slide there, and the principle of counting, you can see this is if an operation can be performed in A different ways independently, second operation can be performed in B different ways independently, and third operation can be performed in C different ways independently, and so on and so on. Then all these operations, one after the other or simultaneously, can be performed in A into B into C into and so on different ways. That is the definition of principle of counting. So similarly, if you see the second part of that slide there, similarly either of these operations can be performed in A plus B plus C plus and so on different ways. So what does it mean? What is the meaning of an operation? You know, the operation, for the purpose of definition, it is named as operation. Operation is nothing but the day-to-day works which we take up is termed as operation here. So let us see an example to better understand the definition here. So let us see the example now. If you see here in the next slide, the principle of counting, yes, example 1, that is, if there are 18 railway stations on a railway line, then how many second class railway tickets are to be printed that enables a passenger to travel from one station to another? Please go through the question carefully. If there are 18 railway stations on a railway line, then how many second class tickets are to be printed that enables a passenger to travel from one station to another? If you go through the problem carefully, the general thinking you must have is this. If you go to the railway station and if you take a railway ticket, for example, you are traveling from Hyderabad to Nagpur, let me say. So then you'll go to the railway station and you'll ask for a ticket in the counter. Then a ticket will be given, and on that ticket you will have the two stations printed like this. It is Hyderabad to Nagpur. Hyderabad to Nagpur, let me say NGP, HYD stands for Hyderabad. Now the railway people, for example, you have become or you have become a railway official, and you have to count how many number of tickets are to be printed for the passenger to travel on all these 18 railway stations. Then you must have the basic knowledge of this principle of counting. Then when you take this ticket, on the ticket you can see that there are two stations printed here, and in the problem given, how many stations do you have there? You have totally 18 stations. Among 18 stations, Hyderabad and Nagpur also two stations are in these two stations are included in the 18 stations. So in the first place, how many stations can be printed? In the first place, how many stations can be printed? That is, from Hyderabad to Nagpur, the ticket is given. Then in the first place, you can print any one of these 18 stations given. Any one of these 18 stations given. For example, from Hyderabad, you will reach to some Karimnagar, or we will reach to Warangal, then Karimnagar, then Balarsha, then Nagpur. Like that, all those stations can be printed here. So in how many ways the first operation of printing the first station can be done? Printing the first station can be done in how many different ways? It can be done in 18 different ways. Understand it? 18 different ways. So if one station is already printed, then how many stations are remaining that are to be printed in the second box? Because one station is already occupying the first place, the remaining stations are to be printed in the second place. How many are they? Remaining are 17. Then you may think, sir, why not it is 18? Or you can understand that you never take a ticket from Hyderabad to Hyderabad. That is why when you take any ticket, the two stations will be different and it will not be same. So when one station is occupying already one place, that station is to be eliminated in the second place. So here, in the principle of counting, the first operation of printing the station in the first place can be performed in 18 different ways. 18 different ways. And the second operation can be done in 17 different ways. So these two operations, one after the other or simultaneously, can be performed in 18 into 17 different ways. You can count it, of course. 8 sevens, 6, 1, plus 2. So the number of second class railway tickets that are to be printed are 18 into 17, that is 306 number of tickets are to be printed in this case. So performing the first operation can be done in 18 ways. Second operation can be done in 17 different ways. These two operations, one after the other or simultaneously, can be performed in 18 into 17 different ways. Okay. Similarly, if you go to the second example, Mr. Rahul has 5 different colored trousers, 7 different colored shirts, and 3 different colored blazers to wear. How many, number 1, different colored triads he can wear in the same order? So what does it mean? You can see the problem carefully. Please go to the problem once carefully. That is, number of trousers or 5. Trousers are nothing but pants, I can say. And number of shirts or 7. And number of blazers or 3. Now, number of how many different colored triads he can wear in the same order. In the same order means first a trouser, then shirt, again on that one blazer. That is the order. This is triad. I termed it as triad. So in how many ways it can be done? And you can see how many trousers are there. Let me say trouser for the better understanding. T1, T2, and it is T3, T4, T5. And shirts S1, S2, S3, S4, S5, S6 and S7. These are the shirts. And blazers, B1, B2 and B3. Now let us start from the first trouser and first shirt. So he's wearing the first trouser on that one. First shirt he's wearing. Then for this combination, how many blazers he can wear? Number 1, number 2 and number 3. So for the first trouser and first shirt, he has 3 blazers to wear. That means it can be performed in 1 into 1 into 3 different ways. Similarly, for the same trouser, he can shift to the second shirt, and for the second shirt also, again he has 3 ways to go with the blazers. So again it is also 1 into, this is 1 into, again 3 ways. So 1 into 3. So how many will get like that? So for this trouser 1, that is first pant, he has 7 shirts. Again for each shirt he has 3 blazers. So he will get 7 such type of different combinations in this case. 1 into 1 into 3 plus 1 into 1 into 3 plus so on. How many times? 7 times he will get. So it will be nothing but for first pant. This is for first pant. He has how many? 1 into 1 into 3, 1 into 1 into 3, 1 into 1 into 3, so on 7 times. So it is 1 into 7 into 3. These are added 7 times. So for the first pant, he has 7 into 3 combinations. You can understand. For the first pant, he has 7 into 3 combinations. And for the second also, same. For the third also, same. For the fourth also, same. For the fifth also, same. So it will be added how many times? 1 into 7 into 3 plus 1 into 7 into 3 plus and so on. How many times? 5 times. So it should be like 5 into 7 into 3. Understand it? So the first operation is nothing but the wearing the trouser here, and second operation wearing the shirt, and third operation wearing the blazer on it. So and all these can be simultaneously done in how many different ways? 5 into 7 into 3, which is nothing but this is 35 into 3, which is nothing but 105. That means with these 5 trousers, 7 shirts, 3 blazers, he can create 105 different combinations. 105 different combinations. So this is a better example to understand the principle of counting. The first operation can be performed in 5 different ways. Second operation can be performed in 7 different ways. Blazer, wearing the blazer can be performed in 3 different ways. So all these can be simultaneously done in 5 into 7 into 3, which is nothing but 105 different ways. Now, coming to the next question, please go through that. How many ways he can wear either trouser or shirt or blazer? Either trouser or shirt or blazer. This is and. Trouser and shirt and blazer. But the second case, if you see that, it is either trouser or shirt or blazer. Okay, so now the first operation of wearing the trouser can be done in how many different ways? It can be done, you can see, in 5 different ways. It is 5 only. Either this or this, that is, or shirt can be done in 7 different ways, and blazer can be wear in how many different ways? 3 different ways. So either this or that or this can be done in 5 plus 7 plus 3 different ways, which is nothing but 15. Find the difference here. Very basic thing where the students generally used to ask the questions like this. Why should we add and why should we multiply? Understand it clearly. And in the previous case we have multiplied, in this case we have added. The reason you understand it, come to the previous slide please.